Assalamu alaikum and hello everyone. Today, Group H will present to you the Lajak Kurui assignment. We Group H, Liao Bunkai, myself Ismail Izzat, Nur Najwa and Hafiz Daniel from Group H. I will start with part A, and this is the data that given to us, that is data for H. I will summarize the sample data in terms of weight, relative density, and tensile strength. And each of them, morning, evening, night, I have divided and calculated using Excel. I have get the mean, median, variance, standard deviation, maximum, and the minimum. You can see right here. Next, I conclude the graphical presentation for this project. This refers to the weight. As you can see, this is the weight graphical, and this is the relative density, and this is the tensile strength. Thank you.
So, my name is Muhammad Abdul. So, I will present the part B. For the part B, we identify that we must use cheesecake test. To be specific, we use good note of fit test. For the hypothesis, H naught weight of standard tablets produced by manufacturers are normally distributed with 200 mg with standard duration of 40 mg. For the H alternative, weight of standard tablets produced by manufacturers are not normally distributed with 200 mg with standard duration of 40 mg. For the next, this is for the test specificity. This is for the weight range. So this is for the frequency of weight. And total up, we got the total frequency is equal to 200. So for the probability or the normal distribution, we find the probability using the standardization. We use Z instead of X. So this is the probability. So for the expected frequency, we use the expected frequency. We use the number frequency times by the probability here. So we add on also, we got 200. So for the cheesecake test value, we use this formula: OI minus I1 EI squared over I. So sum of the expected is greater than 5. So we must merge sum of the category here. So like this and this. So we all have 1, 2, 3, 4, 5, 6 categories. So number 3 is equal to 6. So when we add all, we have a number of 5.7351. For the division rule, sum of the expected frequency below 55. So sum column merge. So you can calculate that at the category after the merging, we got a K is 6. So for the degree of failure, we can calculate it. We got 5. So this is for the critical value for the 0.05 alpha and degree of freedom 5, 11.04705. For the cheesecake value test, when we add on, we got 5.7351. To be note that we get H naught if cheesecake value test higher than the critical value. For the conclusion, since the cheesecake value below than the critical value, we fail to reject the H naught. We conclude that the data of Laku does follow the normal distribution of normalization with the mean of 250 mg and the 14 standard deviation at alpha equal to 0.05. That's all from me for the part B.
Assalamualaikum and hi, I am Nur Najwa will present part C. In this part, I will use analysis of variance ANOVA, and for the hypothesis, H null mu1 equals to mu2 equals to mu3, and H1 mu for at least one ij I not equals to j. And for the test statistic, I total up the weight and n at every shift as you can see in the table. So this is my calculation on how to get F test, which equals to MS treatment over MS error, and I summarize it in ANOVA table. For division rule, H null will be rejected if F test more than F alpha V1 V2. Alpha equals to 0.05, V1 equals to 2, while V2 equals to 197. And from this table, we will get 3.00. So for the conclusion, since F test 0.7280 less than F alpha V1 V2 3.00, then we fail to reject H null. We conclude that there is no significant difference between tablet weight from different shifts at 0.05.
Hi, my name is Lajak from Group H, and today I'm going to present the part D of our report. So this is the question for part D. We are going to find the prediction of the tensile strength for tablets that show low relative density values of 68%, 74.3%, and 80.1%. And we also comment on the validity of the model that we have used to carry out this prediction. First, we fit the simple linear regression line. The equation for fitted simple linear regression line, y hat equal to beta naught hat plus beta 1 hat x. Beta naught hat is representing the intersection, and beta 1 hat is representing the slope of the gradient. For our group, we use Excel to do the regression, and this is the summary output of regression using Excel. So from here, we can see that beta naught hat is equal to 0.3552, and from here we can see that beta 1 hat is equal to 0.0767, and we substitute these two values into the equation, and we will get y hat equal to 0.3552 plus 0.0767x. After getting the equation, we substitute the value of relative density, then we need to test to get the prediction of the tensile strength. So to test the validity, we will do the simple linear regression analysis. So for this analysis, we will use alpha equal to 0.05. This is our hypothesis. For our group, we are using ANOVA approach. So from the ANOVA table that we get from the summary output of Excel, we can see that our p-value is 2.9813 times 10 to the power of negative 49, we can get from the significant f. So for decision rule, we will reject null hypothesis if p-value is smaller than alpha. Conclusion: since p-value is 2.9813 times 10 to the power of negative 49, which is smaller than alpha 0.05, we will reject the null hypothesis. So we can conclude that there exists a significant relationship between relative density and tensile strength. From the table above, here, we can obtain that the value of the sample correlation coefficient R from multiple R, which is here. And we get the R equal to 0.8171, which is between the range of 0.70 and 0.89, and it is categorized as a strong strength while the direction is positive. So we can conclude that there is a strong positive linear relationship between relative density and tensile strength. Last, for the validity, the model that we have used to carry out the prediction is valid, as we obtain that there exists a significant relationship and also a strong positive linear relationship between relative density and tensile strength.